Good day. Today is 18 October, Wednesday. Welcome back to CSC 241 Computer Architecture. I wanted to call your attention to the Module 3 assessment. So by this time, you should have submitted a more complex logic gate diagram. You should already have completed the logic gate E solution. And we may take time to walk through the logic gate solution today. But basically, we need you to go ahead and complete that and get that in so that we can log some credit for you. We're repeating an HDL simulation of your hardware design. So you're going to take the drawing that you submitted, and with that drawing, you're going to use the same drawing as part of the 3.2 solution. So you'll take the diagram from 3.0 and put it in here, and then you'll build a truth table, canonical expressions, valid logic statement. You'll do the same thing that we did in Module 2, except that it's a significantly more complex logic gate. So you're going to add another logic gate. 3 of them have to be different. 1 of them has to be an XOR, an XNOR, or a MUX. And we've been assisting students one-on-one with this. And we'll go ahead and use the rest of our time after we walk through the logic gate E solution. So, not to be confusing, we're going to show you how to resolve the logic gate E truth table and to get a working solution out of the that assignment. The Module 3 solution itself is different, where you're building your own HDL. Okay, so just want to make sure we're straight about that. You should be wrapping all this up, which means you're ready to take the Module 3 assessment. And that's the 3.3 assessment. It is due 10 a.m. Friday, and extensions will not be possible. We must log your first attempt of the Module 3 assessment no later than 10 a.m. Friday, this Friday. And so you have roughly 48 hours to go ahead and complete that. You can complete the assessment without having the solution submitted or the logic gate E, but you're going to want to reference the logic gate E step by step that we walk through in a moment. I'd also like to tell you that we're going to be putting the final version of the Module 2 assessment out in Module 2. And some of you have not completed the Module 1 retake. So for whatever reason, there are still individuals who have neither reconciled their mistakes on the Module 1 assessment, nor have they logged their final attempt of the Module 1 assessment. And so this is something that needs to be done at this time. So if you haven't reconciled your Module 1 assessment errors and you haven't completed the retake, you're going to want to go ahead and finish the retake of the Module 1 assessment. Now, I did want to call out something to you. For those of you that have taken the second attempt of the Module 1 assessment and will soon complete your final attempt of the Module 2 assessment, right? So you have plenty of time to complete the second attempt of the Module 2 assessment. You have to log your first attempt of the Module 3 assessment by 10 a.m. this Friday. So in terms of priorities, if you haven't completed this from Module 1 yet, you need to do this now, today, as in right now. Rearrange your schedule, call folks, adjust your priorities accordingly, because this should have been done for weeks now. And what's going to happen is that we're going to end up zeroing out these assignments. So if you haven't, this is your last opportunity. Okay. I will send one last reminder and that's it. You'll have until the middle of next week to retake the Module 2 assessment and to retake the Module 3 assessment. Since these are very similar in nature and the content is real similar, we'll give you until the middle of next week to log your final attempts of the Module 2 assessment and the Module 3. So even though we post this, it's not due anytime soon. It's the Module 3 assessment that has to be done by 10 a.m. Now, what we're finding is that the students that miss their first attempt, we go over it in class. Once we've done the item analysis of the assessment, that recording is out online in the resources folder, and we can't give you access to repeat, to go ahead and take it at that point because we've walked through all the answers. And we still have students that ask me to let them take it, and we can't. What you can do is take the second version of the module assessment and reconcile that one if you don't have, that first attempt logged. Let me update my screen. Are there any questions about what we just explained? Any questions or comments? Everybody understands you have to log your first attempt by 10 a.m. Yes?
Yes.
Okay. So what I'd like to do now is walk through the step-by-step to solve logic gate E. Can everyone see the screen?
Yeah.
Yeah.
Okay. So one of the things that you're going to need is a three input template. And if you don't have that already, you can get the templates in Module 2 in the resources folder. There are templates. We'll go ahead and download this. So I have a 3-input template downloaded. I'm going to go into this and I'll call this logic gate E. And since I'm going to be adding more columns, I'm going to go ahead and turn this in design mode so that it's in layout mode. I'm sorry, in layout mode. I need to enable editing, and I'll go ahead and in layout mode, I'll change the orientation to landscape mode so that as I'm looking at this, I've got more room to expand and add columns. Does everybody understand what I just did there?
Yeah.
I'm also going to decrease the margins to narrow just so I have, again, more room. And if I look, I'm going to be flipping back and forth with this diagram. So I'm going to pull the tab down. And then when I use Alt Tab on my system, I can kind of bounce back and forth, right? So I have capital A, capital B, and capital C. Those are the 3 inputs for my logic gate E diagram. The only 2 types of logic gates that I'm using are ANDs, but I have 3 of them. And if I start at the top and on the left-hand side, this would be the first AND. And as I'm coming down, this would be the second AND. And this would be the third AND. And for sanity's sake, I'm going to call this AND1, no space, AND2, AND3. I haven't labeled W's, but I will in just a minute. So I also have ORs. This is the first OR. I'm going to label this one OR 1 and OR 2. So as I take the inputs, I have to feed them into each logic gate and perform the logical operator, in this case an AND. Sometimes with my truth table, as I'm feeding those ones and zeros in, those are split. So they are applied to the bottom input here, but then if you follow down, there's a short hop in the wire, and that becomes the input of the bottom and 2, okay? So on my table, I'm going to put capital A, capital B, and capital C. Everybody with me so far?
Yep.
And I'm also going to do this. So by now you should be in the habit of being able to do this. And that's pretty simple. So because I'm also dealing with single letters and there's space is an issue, I'm gonna slide these over so that they're a little closer. And then that way when I insert columns, I'm gonna have more room. So let's start. Any questions so far about what we've done?
Nope.
This is called Q, by the way. So if I look at my diagram, the output is labeled capital letter Q, and that's what I'll use for my table. So what I'd like to do is come up with the first piece of this. I'm going to take the inputs for A and B, and I'm going to feed them into AND 1. So I need to combine inputs A and B on the truth table with an AND. So I'm going to insert a column, and I'm going to do it to the left of where I'm highlighting, insert to the left. And I'll call this AND 1, A, B. So this column represents what happens when I take the A inputs and the B inputs, and here's AND 1. So when I AND, if any of the inputs are 0, then the output is 0. So what do I get for a result here? Can anyone help me fill this in? What am I going to have in this column?
That would be 0.
Say again?
0.
0 is correct. What about the next one?
0.
0, yeah.
0. 0.
Uh-huh.
0. 1,
about
1.
this? 1, 1. Okay.
Yeah.
Now, let's pretend that the output of this is W1. Does everybody understand the reference there? The output is, I'm going to label this wire W1. So when I get this result coming out of AND 1, it's going to be fed into W1. All right. So I'm actually going to take this a little further, and I'm going to say W1. And I'm going to make this smaller. And I'm actually, yeah. I'm gonna make this like that. So this column is now what I call W1, and it's the result of ANDing A and B inputs. Does everybody see what I just did there?
Yeah.
Okay, good. Now your convention may be different. When you attempted your solution of the logic gate E assignment, you may have used different labels in the column. The important point is that you have a distinct way of showing those results, because what I'm going to have to do is take these results and feed them in elsewhere. All right. Okay, moving right along. What I'd like to do now is take the next logic gate, OR 1, and I'd like to feed in B and C. So I'm taking the B inputs and C inputs and creating OR 1, and what comes out of OR 1 is W2. Does everybody understand what I'm saying here?
Yes.
So now I'm gonna input, and this is just my own particular choice of doing it, but I'm gonna go ahead and insert to the left. I'm just gonna copy this because it's a little easier to copy and paste. And this is gonna be W2. And actually, I like lowercase w, because that's what we've been doing in our other ones. This is OR 1, and instead of A and B, it's B and C. So I'm going to take B and C and OR them. So it's this column, and it's this column, and it's OR. So what do I have for output here? Who would like to help me?
0,
Say again?
0,
Okay. Next one.
1,
Uh-huh.
1,
Uh-huh.
1,
Yes.
0,
Uh-huh.
1, 1, and 1, yeah.
Yep. So one of the things that's really distinctive about ANDs is how restrictive they are, and how most of the time it's zeros, and there's only a few ones. And then ORs usually render mostly ones, and a single case is zeros. So this is consistent with the behavior we understand. So that's what you're seeing right now. Any questions about how we came up with W2? OR 1, B, and C?
No.
Okay, so now we have AND 2, and AND 2 is different. AND 2 combines C with B. Okay, so if you look at AND 2, the C input is split and it becomes the top input of AND 2, and the B input is split and it's fed into the bottom. So I'm going to do the same kind of thing, and I'm going to put AND 2 here. This time, I'm going to insert to the left, and let's see, is there a W3? Oh yeah, there's a W3 right here. Yeah. So I'm going to put W3, it's an and I'm using C and B instead of A and B. I'm just going to copy this and paste this, and I'll make this a 3. It's an and 2 instead of and 1. The C input is the first input, and the B input is actually the second input. And I'll need to make this a small w, right? Does everybody see what I did there?
Yes.
So now it's the C column and the B column that are ANDed. So what are the results that I'm getting from B and C? That's different than the A and B column that was ANDed, right? So what happens if I AND this value and this value? Can somebody help me fill that out, please? A volunteer, please.
Zero.
0, yep. Sometimes it helps to do this, just temporarily. It just helps temporarily to do this. Right? And then take out the highlight afterwards. Okay. What's the next one?
0.
0, yeah. And the next one?
0 as well.
Uh-huh.
Then 1.
And 1. All right. And then
0. 0. 0. And then 1. Yeah.
and 1. Very good. Thank you. So now I'm going to go ahead and remove the highlights just because I'm not using B and C anymore. I'll save this because I've I want to save. I don't want to lose my work. What's my next step? What should I do next? If I'm going from top to bottom and left to right, which logic gate do I hit next?
Another AND.
Another AND is correct. It's the third AND. What do we have for inputs for this AND?
W2 and W3.
That's correct. W2 and W3. Thank you very much. So I'm going to put in, and then what's the value that's coming out of here?
W4.
So W4, it's an and it's W2 and W3. So on my truth table, I'm going to insert another column. I'll right click with my mouse. That's how I'm getting this. I highlight the column, then right click, use insert to the left. Okay, let's make this a little bigger. So I'll take this, it's an and. So if I paste this in here, the W4 result, I get the W4 result when I use and 3, and instead of C and B, it's W, what do we say, 2? And W3. Does everybody see how I'm getting that logic?
Yep.
Okay, so I'm just doing this in a stepwise fashion. And that's the challenge. It's a challenge to kind of eat the elephant one bite at a time. That's what we're doing with logic gate E. And it's a simple diagram. It only uses 2 different kinds of logic gates. Ands and ors, 3 ands and 2 ors, but it uses the or to accept the output on the very end, and or is very permissive. So it's going to be interesting to see what happens when the output here is Q. Will it turn out to be mostly zeros or mostly ones, right? And again, every situation where electronics are designed to control current, the flow of current, or the lack of the flow of current, that's what we have. So now we have our column. We have to populate our column. We have to use 2 and 3. So I'm going to highlight 2 and 3 just because this is what I'm doing. I'm combining it with an and. I'm not using an XOR or an, you know, not using a not, just using an and here. Can someone help me fill this out, please?
0,
Mm-hmm,
0,
mm-hmm,
0,
mm-hmm.
1,
Yes, excellent.
0, 0, 0, 1.
Excellent. Outstanding. Thank you. I'll take this off. I'll highlight the whole column. Let's look at our diagram. I have a W4. It feeds into the bottom of this OR. I have a, what is this? What do we label this?
W1.
W1. W1, thank you, is the top input of the OR. W4 is the bottom input of the OR. And this is OR 2. So we can basically borrow from the other OR column, just like we did. And then what we'll have is our final output. So this is actually Q. In other words, I could take this column and that's what I get. So Q is, let's look at our diagram again. It's an OR, it's OR 2 with a W1 and a W4. OR 2. Actually, I'm going to do this. It's cleaner this way. W1. W4. And it's OR 2. Whoops. Dang it. Don't know why it's doing that. Does everybody understand how I got this?
Yes.
So I want to highlight my columns again, just so I don't miss what I'm combining. Can someone help me render? And I'm also going to make this bold, right? So I'm going to make this big and bold. What's my final output here?
Zero,
Yes.
0,
Uh-huh.
0, 1,
Whoops. Yes.
0,
Go ahead.
0, 1, 1.
That's correct. That is my final solution. Now, if I go ahead and leave this the way it is, which version of the canonicals do I want to do? Which is easiest? To do the standard canonicals where true is the case, or the reverse canonicals where 0 is the case?
Standard.
Standard is correct because there's only 3 inputs. There's only 3 combination of inputs that result in a true, but there's 5 that result in a false. So if I chose to express the canonicals using the reverse convention, I'd have to have 5 different expressions. But instead, what I'm going to do is work the canonicals. Standard canonical. Okay. And let's take each case. I need A, B, and C, the original input values. So I'm going to take the highlights off again. And I'm going to go back and put the highlights on A, B, and C, because I want that to be my focus now. I know this takes a little bit. If you have, if you practice more, you get faster at it. It's this case, and this case, and this case. So I think what I want to do is highlight this a different color. Let me do something like this, right? Your eyes play trick on you. They play tricks on you. So what happens is that when you're in a hurry, visually, there's all these ones and zeros, and it's easy to read the wrong one. So when you're under the gun in an assessment or an exam, or you just want to get your solution done. And what I'm advising here is that you take the time to do it in a stepwise fashion and use color coding, because that's going to keep you from making simple mistakes where you're reading the wrong column and you're in a hurry, right? So panic is not your friend. So these are the three cases that we're pulling out here. True, true, and true. So can somebody help me write my canonicals? The first case where it's true, what's the value of capital A? Is it A or A tick?
A tick.
A tick. That's what this is right here. B and C are true, so I can put B and C. I'm going to put some spaces. Now I'm ready for the second case. What do I have in the second case right here? Volunteer, please. Anyone?
A, B, and C tick.
A, B, and C tick is correct. Does everyone see how we got that?
Yes.
All right. Last case. That's easy. What is it?
ABC.
ABC, no ticks. Yes, thank you. Now, here's the fun part. I have the truth table. I have the canonicals. I can create a logic statement, and then I can go into my HDL environment, and I can actually create this thing in the HDL simulation environment. But what I want to do is ruminate. Before I write the logicals, I want to see if there are any common conditions for the inputs between each of the three expressions. What am I saying? If I want to write a simpler logical expression, what I'm looking for are common values between the three expressions. Is there an input that's the same in each of those three cases? Well, it's not A, because A tick and then A.
B.
Yeah. Okay, it's B. Does everybody see what we're saying here? Here the C is true, but the C is false. Here the C is 1 and it's a 0, but B is a 1 in every single case. Does everybody see that?
Yes.
Okay. So if we want to write a logical statement, right? We can say out equal 1 when B, I'm going to put this in all caps. Actually, I think what I'll do is I'll put Q. Why am I putting Q? Because that's what the diagram showed, okay? So Q is assigned or it renders a 1 when B is equal to this, and let's do this.
Well, coach,
Yeah.
may step down.
Guys,
Don't know what up, but
Let's look at
Okay,
the
yeah.
other.
me even though when
Let's look at the other variables. So B is always 1. And if A is false or A is true, yeah, I think what happens is that these two are the same. So when A is true, it doesn't matter if C is false or C is true. Does everybody understand what I'm saying there? Look at the two statements. When A is true, it doesn't matter if A is false or A is true. So I can do this. What's the other case? It's this particular case. When B is true, A is false, and C is true. So I'm going to write it like this. A equal 0. B equal 1. C equal 1. So in these two statements, as long as A is true, it doesn't matter what C is. That's why we have it stated like this. But in this other case, when A is false, B and C have to be true. And that's what makes this work, okay? So that's my logic statement. Are there any, now there are other ways to write the logic statement. You could just say Q equal 1 when A equal 0, B equal 1, C equal 1, or A equal 1, B equal 1, C equal. You can just state each one explicitly. You could write your logic statement out just like that. It's just more concise and it's cleaner if you isolate those conditions, right? So this first line takes care of these two cases, but it doesn't take care of a case when A is false or 0. And that's what that second line does, okay? Does everybody see what we did here? You can take the diagram and your truth table and the canonicals and the logic statement, and then you go into the HDL, and you can basically follow in the HDL the W1, W2, W3, and W4, okay? Any questions about our walkthrough of the Logic Gate E assignment? Thank you for joining us. Good luck with your first attempt of the Module 3 assessment. Please have it completed no later than 10 a.m. Friday, 20 October, 2 days from now.